Hello there guys, welcome to my channel. Okay, in this video I'm going to explain about chemistry paper 2 and this is 22 May June 2021. Okay, the time limit here is 45 minutes. Okay, now let us move to the first question. Okay, number 1. A gas is released at point P in the apparatus shown, and you can see here there is a dam universal indicator paper. Okay, please remember the color of this universal indicator, where you have acid, neutral, and also alkaline. Okay, so in acid you have a red color, then it will be slowly changing it to orange, yellow, and at neutral it will become green. And moving towards slightly alkaline, it will change to blue and then purple. Okay, so these are the colors that you have to remember. Okay, now which gas turns the dam universal indicator paper red most quickly? So they are asking for the most acidic. Okay, now ammonia is more to alkaline. Okay, alkaline, so definitely it's not the A. So chlorine, yes, it is acidic. Hydrogen chloride, yes, it's acidic. Sulfur dioxide, yes, it's acidic. But the most acidic here is hydrogen chloride. Okay, they're having a pH of 1. Okay, now we move on with number 2. Okay, for number 2, a mixture of colorless compound is separated using a chromatography. Which type of reagent is used to detect this compound after separation? Okay, since it is colorless, we have to make it colored. So the name of this reagent is, we call it as a locating agent. Please be aware, this question has been repeated in the paper 4 and also paper 2 for the past 3 years, since 2017. Alright. Okay, now for question number 3, which statement about paper chromatography is correct? Okay, and this is the basic drawing of this chromatography experiment. Okay, and then here the solvent must not be reaching the line. Okay, it must be below the line. The line that I mentioned here is, we call this as a baseline. Okay, this is the baseline. This is where all the substance will be located. Okay, and this is, we call it as a solvent front. Solvent front, and from here to here is where we will be calling the RF value. And through diffusion, the solvent normally is alcohol. So through diffusion, it will bring the substance, alright, depending on their diffusion rate, and it will be separating the substance into their components. Alright, okay, now let us look at one by one. A solvent is needed to dissolve the paper. Not really. Okay, so we can keep it aside. Okay, paper chromatography separate mixtures of solvent. No, they are separating the substance here, so it is wrong here. The solvent should cover the baseline, which is not true. So it should be below the baseline. Okay, please remember this. The baseline should be drawn in pencil. Yes, because pencil, it contains carbon. So carbon will not be dissolved in alcohol. So your best answer here will be D. Okay, now let us look at number 4. Okay, element X has 7 protons. Element Y has 8 more protons than Y, which means this is about 15 proton. Okay, now if you're looking at proton and electron, they must have the same numbers. Okay, so here must be 7 electrons and 15 electrons. So now we look at their electron arrangement, so here's 2, 5, and for 15 is 2.8.5, which means they are in the same group. Okay, they are in a same group, which is a group 15, and a different in a period. So this is one period more. It means if you look at the periodic table, so the X will be on top, and then the same Y will be at the bottom. So this is 2.5 and this is 2.8.5. So Y has a one shell extra. Now let us look at the options they give. Y has more electrons, electron shell than X. Electron shell than X. Okay, so yes, we keep it aside. This is correct, but we keep it aside. Y has more electron in its outer shell. No, they have the same. Okay, they have the same, which is 5 and 5 here. So B is wrong. Y is in a different group. No, they are in the same group. Wrong. Okay, Y is in the same period. No, they are same group but a different period. Okay, so number 4 is A here. Alright, now let us move to question number 5. Okay, number 5. A covalent molecule Q contains only 6 shared electrons. Okay, what is a shared electrons? It means when you have X and Y, example. Okay, this is what we call it as a shared electrons. Okay, now when we look at the ammonia, so over here we have to draw the Lewis structure diagram. Okay, so I just put a dot for nitrogen and the cross for hydrogen. Okay, so as you can see here, there is 3 bondings and 6 shared electrons for ammonia. Alright, so this is the most possible answer. Now we look at chlorine. Chlorine has 7 electrons, electrovalence. Okay, so they have only 1. Alright, they share only 1. So which is wrong. Methane, okay, carbon has valence electron of 4. Okay, they have a 4, so I put a dot here. And for hydrogen, I put the X here. They have more shared electrons, which is about 4. 1, 2, 3, and 4. So this is not the answer. Now if you look at water, let me clear this stuff. Okay, now if you look at water, okay, oxygen has about 6. So I can say I put here 1 and 2, 1, 2, so total about 6. Okay, now hydrogen, it has 1 electron. They have a forming. Then they have only 4 shared electrons. It means like 2 bondings. So this is not the answer. So your best answer here is A. Okay. Okay, now let us move to question number 6. Okay, for question number 6, information about 4 substances E, F, G, H is shown, and this is the melting point. Okay, electric conductivity. Okay, it does not conduct when solid. If it conducts when solid, and this is a metal, this one, okay, look at G, it does not conduct. So it should be a non-metal substance. Conducts when molten. Okay, now it does not conduct when solid. Okay, now let us look at the options they have. If you look at graphite, right, they do conduct electricity when it's in solid. Okay, they do conduct. So poly is a non-metal and they do not conduct electricity in solid or in a molten form. So here they have only 4 choices, which is sodium chloride. Okay, so let me just label it down. So we have 4 choices over here: graphite, sodium chloride, polyethylene, and silicon oxide. Is there any other than this? No. Okay, now the most suitable. So the most suitable, we have to look at the one that conducts when solid. So compared to all these 4 choices that they provide us, graphite is the one that are capable of conducting electricity in solid form. Okay, this is done. And sodium chloride. Sodium chloride, as we know, is an ionic bonding. It's an ionic bonding, and it does conduct electricity when it's a molten form. So here will be sodium chloride, that is by H. And we have 2 choices now: polyethylene and also silicon oxide. Silicon oxide, okay, this is a macromolecule, right? Macromolecule, and this macromolecule, it has a very high melting point compared to polyethylene. So here should be silicon oxide. Here's silicon oxide for E, and this is a polyethylene. Okay, now let us find the most suitable answer here: silicon, graphite, polyethylene, and sodium chloride. Okay, we got the answer, which is D here. Okay, so I hope you understand this. Okay, now we go to question number 7, which is a second page of the paper. Okay, number 7, chemical compound formed from group 1 element. This is metal, and this is a group 17, which is a non-metal. Okay, contains ionic bonding. Yes, metal and non-metal, they'll form an ionic bonding. Okay, how are the ionic bonds formed? Ionic bonds form, okay, this one will donate electricity. It will donate, not electricity, sorry. It will donate the electron to the non-metal element. It will receive. Okay, now let us go through one by one. Electron are transferred from group. No, it's wrong. They're supposed to transfer from 1 to 70. So this is shared, so which is wrong. This is ionic bonding, they do not share. Only covalent they share. Electrons are lost at group 1 at both group. So lost is here, gain is at here. Okay, the electrons are transferred from group 1 atoms to group 17. Yes, this is your right answer. Okay, this is for number 7. Number 8, some information about particle Q, P, Q, R, S is shown. Okay, which 2 particles are isotopes of the same element? Okay, isotopes here, the proton number must be the same proton number, but different in neutron and also nuclear. This is different. So now if you look at it here, since the electron number is the same with the proton number, so 6 and 6, which is a P and S, and 10 and 10, so you can say P and S, O, Q and R. But if you look at this, okay, now when we P is 6, and both of these nucleon, okay, here's 12, and then we put the S, this is 6, and here is 14. Okay, now let us do the same thing for Q and also R. For Q is 24 and 10. For R is 16 and 10. Okay, normally for isotopes, even though their numbers, the nuclear numbers is different, but their range will not be too far. It will be very near. Example like this, 12 and 14. Okay, like if you look at chlorine, we have 35 chlorine and chlorine 37. So these are the examples of the isotopes. But if you look at Q and R, the range here is quite far. Alright, so this one most probably cannot be from the same element. So your best answer here will be P and S, which is B. Okay, now we'll move on with number 9. Okay. Chlorine gas will react with iron metal. Exactly 21.3 gram of chlorine react with 11.2 gram of iron. How many iron atoms react with 30 molecules of chlorine? Okay, from here we need to calculate the moles of the chlorine. Now 21.3 divided with 35.5. For this is for the chlorine. Okay, for chlorine. And then for iron, ferrum, 11.2 divided by 56. Okay, now just let us calculate the answer, the mole. Okay, here I'm getting, for chlorine, I'm getting here 0.6 mole. And over for iron, 11.2 divided by 56, I'm getting here about 0.2. Okay, to be more clear, we can do an equation. Chlorine gas with iron, it become iron fluoride. Okay, so here we have 1. Okay, we have to balance this. Balance it first. So here getting 2, and here is 3. So we have here about 3, the ratio, and 2 here and 2 over here. Okay, now from what we get over here, this is 0.6. Okay, 0.6 mole. And here for number 2, iron, here we have 0.2 mole. Okay, and then please remember, whenever you have this question, please redo the equation to make sure. So the iron and the chlorine, we will have a 2 and 3 ratio. So if here is 30, okay, 30 chlorine molecules, and here will be about 20. So your answer here is C. Okay, now we will go through with question number 10. Okay, in separate experiment, electricity was passed through concentrated aqueous sodium chloride, okay, and molten lead bromide. Okay, what happened over here is, let me zoom this and I'll explain to you over here. Okay, when we have a sodium chloride concentrated, okay, let's say, let me separate this into ions. So we have here sodium, chlorine, hydroxide, and also hydrogen. So the one that will be discharged at the cathode side is hydrogen. Since it is concentrated, it will be affecting only the anode part, okay, and the side of anode. So it is not a hydroxide, but it is a chlorine. So this is at the anode. Now the another one Here another substance that they are talking about is a molten lead, plumbum 2 bromide. Okay, this is a molten. Okay, molten, there's only two, which is a plumbum and also bromine. So this one will go to anode, and you will have a brown color gas forming, and this is a cathode. All right. Okay. Okay, now look at the question. What would happen in both experiments? A halogen would be formed at anode. At anode, yes, definitely. So we keep A first. A metal will be formed at cathode. They're asking for the both experiments. All right. This is metal, but this is not metal. So B is wrong. Okay, hydrogen will be formed at anode. Wrong. All right. So anode is either chlorine or bromine. Hydrogen would be formed at the cathode. Partially right, but not for both. So your best answer here will be A. Okay, now let us look at number 11. Okay, for number 11, a reaction involving aluminum is shown. Okay, we got this. Okay, there's a water and oxygen. They want the value of X and Y, balance the equation. So here we have, okay, here we have, look at hydrogen. Here we have about 12, right? Hydrogen here is 12. Now look at here, this is 3, and we need to form the same amount of hydrogen. So here should be 4. Here must be 4. So 3 times with 4, you got 12 hydrogen. Now same goes to with oxygen, right? Oxygen 3 times with oxygen. So you got 3 oxygen there, multiply with 4, so you're getting 12 oxygen. Now look at here. This one you already have 6. So 12 minus with 6, you have another 6 more oxygens. But here you have 2. So here will be 3. Okay, Y is 3. X is 4. And look at aluminium. Here's 4. And here should be 4. So it's the same. Okay, it's the same. So should be 4 and 3. D, your answer. Okay, so this is for number 11. Okay, 4 different fuels are used to heat a beaker of water for the same amount of time using apparatus shown. You have a thermometer and 200 gram of water, screen to reduce draught, okay, stirrer, and we have a spirit burner, fuel. Okay, now let us look at the question here. The initial temperature of the water and the temperature after heating by the fuel are recorded. Which fuel releases the most heat energy? So here we have to look at the differences. Differences between the temperature after heating minus with the initial. So here will be 46 minus with 17. Here you are getting about 29. 52 minus 24, you are getting here about 28 for the second one. And here you'll be getting about 35 for C. And here's about 32. Okay, these are the differences. So the higher the difference in temperature is the answer, the most heat energy. So C is your answer. Okay, all right. So this is for number 12. This is the calculation. Okay, now let us go for Question number 13. Okay, for number 13, an excess of calcium carbonate react with the dilute hydrochloric acid. Volume of the carbon dioxide produced is measured. Okay, this is a volume of carbon dioxide. The results are shown as experiment 1. Okay, the experiment is repeated with only one change to the reaction condition, and you have a jump in reading of the volume of carbon dioxide. So okay, if concentrated, okay, now let me draw another graph here. Okay, the first one, the concentration of acid. If the concentration of acid increases, so what will happen basically here is you will have this type of graph increase. It means the green color is the original, and you will have the blue color line, which makes the experiment to go in a faster rate. Okay, now the second one, volume of the acid increases, so you will have like more molecules of acid to react with calcium carbonate. It's a possible answer. Let us look at C. Mass of calcium carbonate increased. Okay, remember they already mentioned here it is an excess, so increasing the mass doesn't work. Okay, doesn't work. So the D is the calcium carbonate is powdered. If it's powdered, you will go to this kind of graph. So your best answer here will be boy. Okay, so this is for number 13. Okay, for number 14, when the sulfur is heated, it undergoes a change in as it melts. Okay, all this freezing, melting, and what else? Evaporation, boiling, condensation, which is it all involves as a physical. Okay, this all is a physical changes. So number 1 is more to physical. Okay, further heating causes the sulfur to undergo a change and form sulfur dioxide. Okay, now they are changing the entire molecule structure. So here you will have chemical changes. So your answer here is C. Okay, number 15, false statement about the effect of increasing the temperature on a reaction are shown. Okay, so regarding the reaction and also increasing the temperature, let me show you. Okay, for a reaction to occur, it means like when you have A and you have another molecule B, when they collide and you are forming a C product. Okay, so for this to happen, you need to have two things. One is a right orientation. This is when they are colliding. Okay, so they have to collide in this way. That's how they form the product. The second one is they need to have a sufficient activation energy. If they do not have a sufficient activation energy, what happens is they will bounce back. Okay, they will bounce back after they heat. Because of lacking of the energy, they will bounce back. Okay, so when the temperature is increased, so what happens is all the atoms will be gaining kinetic energy. Kinetic energy will increase. So what happened over here, you will have a frequent collision. If you have a frequent collision, you have higher chances of getting the reaction to occur, because you have enough sufficient energy, activation energy, and also some of the molecules will be in a right orientation. The probability will be higher. Alright, that's all. So now let us look at the question here. Okay, now the activation energy becomes lower. No, because when they are traveling faster, okay, due to their increase in kinetic energy, so the activation energy will become higher. So this is wrong. Particle moves faster? Yes. There are more collision between reacting particles per second? Yes. There are more collision which have greater energy greater than activation energy? Yes. The probability is more higher. So your answer here is 2, 3 and 4. C is your answer. Okay, now let us look at number 16. Okay, an example of a redox reaction is shown. Alright, so over here, please remember, if you have an atom or molecule, it is 0. Their oxidation number is 0. Here is 2 plus. Here is 0. Here is 2 plus and reduced to 0. So if your oxidation number increases, so it means the zinc has been undergoing oxidation. So let me just write it down over here. Oxidation is zinc. Reduction is copper 2 plus. And if you're talking about agent, oxidation agent, which one helps the zinc to get oxidized? Is copper. Okay, so this is copper. And same goes to reduction agent. So here you have zinc. Okay, now we go through one by one. Zinc is an oxidizing agent, so it's wrong because it itself is oxidized. And this is right. And it reduces. Okay, it reduces. Okay, copper 2 plus. So your answer here will be donkey. Okay, now we go to number 17. Okay, when bismuth chloride react with water, what precipitate? Bismuth oxychloride is formed. The equation for the reaction is shown. Alright, the reaction is in equilibrium, which changes cause white precipitate to dissolve. Okay, adding water does not have any effect because you already have it in your equation. Okay, number 2 is wrong. So your only choice is boy, which is 1 and 3. So if you look at adding acid and also sodium chloride solution, okay, both of these, they are capable of removing bismuth, okay, from its molecule. So your best answer here will be boy. Okay, now let us look at number 18. Element X forms an oxide that neutralizes sulfuric acid. Which row describes X and XO, which is the oxide? So if you look at our periodic table, group 1 and group 2, okay, group 1 and group 2, which are metal, they are soft metals, and their oxides is they have alkaline characteristics. Okay, their oxides, they have alkaline characteristics. So which means is boy, metal and also basic. Okay, now look at number 19. Information about the solubility of salts is shown. Chloride, nitrate and sulfate. So nitrate, all is soluble. Chloride is soluble except for lead and also silver. If we look at sulfate, soluble except for barium and lead. Okay, aqueous solution of which two compounds would produce a precipitate when added together. Okay, now here we have to go through one by one. Okay, Barium will combine with chlorine. You have barium chloride. Calcium with nitrate. So you have the calcium nitrate. Okay, calcium nitrate is soluble. It is soluble. And chloride, look at chloride, except for plumbum and also argentum, silver, is insoluble. Barium chloride is still soluble, right? So this one does not produce precipitate. Now we'll look at here, copper and nitrate. Copper and nitrate, you'll form copper nitrate. This is soluble. Zinc sulfate. Zinc sulfate is soluble, so not this. Now look at potassium sulfate. Okay, all potassium salt, potassium, sodium, and ammonium. Okay, all their salt here is soluble. Please remember this, guys. Okay, so you have the potassium sulfate and we have sodium chloride. Okay, both of them is soluble. Let us look at the last one, plumbum sulfate. So you have the plumbum sulfate. Yes, plumbum sulfate. Look at here. Okay, lead sulfate. This is insoluble. So we got the answer. And the next one here is a magnesium nitrate. Magnesium nitrate, this is soluble. So you have one is soluble and you have the precipitate. So this is plumbum sulfate and here is magnesium nitrate. Alright, so I hope you understand this question. Okay, this is for number 19. Okay, for 20, the equation shows the reaction between hydrogen and also oxygen. Okay, this is the bond energies. Now, which row shows energy change and the type of the reaction? Okay, for this, we need to calculate one by one. So, for hydrogen is 436 times with 2 because you have 2 here. Okay, now look at oxygen double bond, you have the 495. That's all. So we add on all this. So we'll be getting here 1367 kilojoule. Okay. Please remember one thing. Here, it involves heat, absorbing heat. Okay, it involves absorbing heat. Absorb heat. So which means it is under endo. Okay. At the other part here, this one is to form the bond. If you want to form the bond, you need to release the heat, which means it's exo. And this part is breaking the bond. Alright, this is breaking bonds. Okay, now for OH, O and H. So here we have two bondings. 2 times 2 you got there, about 4. 4 times with 463. So how much is this? So we got here 1852 kilojoule. So the equation here is releasing more heat, okay, compared to the absorbing. So we minus this. We will be getting negative 485 kilojoule, which means it is an exothermic reaction. So your answer here is C. Okay, so I hope you can understand until here.